Hi everyone. So today we're going to work on what is called the additive rule, or you're going to hear me say it additive rule, but it's the addition rule. So we're going to use this when we want to do or, like do one thing or another, where the multiplication rule was for and. So we want to make sure we differentiate between the ands and the ors. So we're going to talk about mutually exclusive because that's important especially with the additive rule. And then we're going to do some probabilities with the additive rule. All right, so let's talk about mutually exclusive. So two events are mutually exclusive. Events A and B cannot occur at the same time. So you can't do both at the same time. All right, you can't be odd and even at the same time. So therefore, they are mutually exclusive. All right, so if there's no intersection, there's no overlap, those are considered mutually exclusive events. If they're not mutually exclusive, all right, so they have to have nothing in common. All right, otherwise they're not mutually exclusive. So an example of that would be these two circles. They have nothing in common. There's no overlap, so they're considered mutually exclusive. Here, they are not mutually exclusive because they have an overlapping area right there. So that's the and part. So mutually exclusive doesn't have an and, all right? There's nothing in common. All right, so let's see if we can do some of this. We just want to be able to identify if events are mutually exclusive or not. All right, so you roll a die. You roll a 3 and a 4. Are they mutually exclusive? Can you be 3 and 4 at the same time? No. So that means these are mutually exclusive events. Okay. All right, let's try another one. You're going to select a male student and then their nursing major. So the question is, can you be male and nursing at the same time? The answer is yes. So these are not mutually exclusive. All right, let's try the blood donor one. Blood donor type is O, and the donor is female. Can you be female and type O at the same time? The answer is yes, so therefore not mutually exclusive. Lost my E there. Okay, why don't you try 4 and 5 on your own? All right, why don't we give those a try, see how you did. Okay, so the first one is not mutually exclusive because a Jack is a face card. And can the vehicle be a Ford and a Toyota at the same time? The answer is no, 2 different manufacturers. So they are mutually exclusive. So remember, mutually exclusive have nothing in common. Okay, why do we care? Because if we're going to do the additive rule, we need to talk about mutually exclusive events. So the additive rule says that events A or B, okay, will occur, and we're going to put, now you're going to be able to tell it's an or problem or an additive problem because it's going to say the word or, is given by A or B is equal to probability of A plus the probability of B minus A and B. Now when I say A and B, that means this is what they have in common. Okay, so if you have something in common, then we're going to subtract that out. Okay. If they are mutually exclusive, then we don't have anything in common, so it's just A plus B. Okay, so let's give these a try. I find these a lot easier than the multiplication ones. So we're going to select a card from a random deck of 52, and we find the probability is a 4 or an ace. So we're going to write this as probability of 4 or ace. Okay, so I have a little diagram in here, over here. First of all, do you see there's nothing in common? So can you be a 4 and an ace at the same time? And the answer is no. Okay, so probability of 4, well, there's 4 4s out of 52 in a card deck. And there are 4 aces out of a 52 card deck. So we're going to say 8 out of 52. And I'm just going to leave it as a fraction, but you can write that as a decimal as well. All right, let's try the next one. You roll a die, and you find the probability of rolling a number less than 3 or an odd. So we're going to do probability of less than 3 or odd. Okay, now, question is, can you be both odd and 3 at the same time? And the answer is yes. Okay, so probability of 3, less than 3 is 1 and 2, so there's 2 out of 6. Plus odds, well, there are 3 of them, 1, 3, 5. And minus what they have in common, which is 1. So that's 1 out of 6. So I don't know why I wrote 5 there. Okay, so 2 6 plus 3 6 minus 1 6 is 4 6. Now you can also write that as 2/3 if you choose to do so. Okay, or 0.66, repeating. Oh, excuse me. Okay, now I just want to point out that what's in common has to be subtracted out. That's what the key is. The common part has to go. Because otherwise you're counting it twice. Okay? See, like here, you're counting it in the less than 3, but you're also counting it in the odds. So it's getting counted twice. So we have to subtract that out. Okay, why don't you try just 3 and 4? Okay, pause the video, try just 3 and 4. Okay, here's 3. You roll a die, and it's a 6 or an odd. So 6th is 1/6. Odds are 3 out of 6, but you can't be odd and 6 at the same time, so there's nothing to subtract out. They are mutually exclusive events, and you get 4 6 and 2/3. Okay, card is selected. You're finding a card is face card or heart. By the way, aces, we're not going to count as face cards. They're going to count as ones. All right? So there are 12 face cards, 3 for each suit, plus 13 hearts, minus, can you be a face card and a heart at the same time? Yes, there are 3 of those, a king, a queen, and a jack. So 12 plus 13 minus 3, there are 22 out of 52, so your probability is 11 out of 26. And again, you could write that as a decimal if you choose to do so. All right, let's look at these. Okay, so these 3, by the way, these all were from a classical or theoretical probabilities, okay, because we could write a sample space and figure that out. This next group are empirical because when there's an experiment or data collected to answer these probabilities. So we have a blood bank, catalogs the type of blood, including positive and negative Rh factors, given by the donors during the last 5 days. The number of donors who gave each blood type is listed below, and a blood donor is selected at random. Find the probability that the donor has type O or type A blood. Okay, so we want the probability of O or A. So the question is am I just going to add them, or do I have to add and subtract what they have in common? Well, here's type O. Here's type A. They don't have anything in common, which means you can't be type O and A at the same time. So I'm going to take my probability would be 184 for O out of our total, which is 409, plus the total of 164 for A out of 409. And I'm just going to add those two together, and I get, what the heck is that? 348 over 409. And again, we should write that as a decimal if we choose to do so. All right, so we're going to find the probability B or Rh negative. Okay, so B or Rh negative. Okay, so B is, let's go back up here. Here's my data. So B has 45. So 45 out of 409 plus Rh negative. Okay, so here's B. Here is Rh negative. 65 out of 409. Okay, does everybody see that there's an intersection between B and Rh? Okay, so there's minus the 8 that they have in common. Okay, so we have to take that out because, again, that's being counted twice. So I got 102 over 409. Okay, and again, write it as a percent. Okay, B or AB. again, come up here. I find the highlight really helps me out. So I'm looking for B or AB. Notice they have nothing in common. There's no intersection between those, so they are mutually exclusive, which means I'm just going to add the two probabilities together. So we're going to get 45 over 409 plus 16 over 409. And I got 61 over 409. Okay. All right, let's do, I'm going to have you guys do some in a minute, but let's do this one together. Probability of the donor is O or RH positive. Okay, so O, RH positive. Okay, so looks like there's an intersection, so we're going to have to subtract. Okay, so I have this on as, I did my paperwork here. So that's this O plus RH positive minus both O and RH positive at the same time. It was 156 over 409. Again, where did I get the 156? If you come up here, there it is, the intersection between the two. All right, so we add and subtract. I got 372 over 409. Okay. All right, why don't you pause the video? I want you to do the next three on your own. All right, let's see how we did. Okay, so for not O or A, so that meant it had to be the other ones, which were 45 and 16, no intersection, so 61 over 409. O and RH positive, so again, O, RH positive minus what they have in common, 372 over 409, and A and RH negative. Again, not mutually exclusive because there's an intersection, so 164 plus 65 minus 25. Okay, needless to say, we probably should write these all as percentages because they're going to make more sense than the fractions as far as like probability. All right, so what have we learned so far? So here's my little summary. Usually I write this out, but I like this chart because it gives you all the probability and the probability rules. So classical, we're talking about outcomes in a sample space, and we know that. Okay. Oh, let's pick a different color here. Let's do this one. So it's a sample space one, and we're equally likely. It's just number of things in the event divided by the total. Here is estimated from an experiment. So empirical is experiment. Let me change that color. Give everybody their own thing here. Okay. Sample space, outcomes, that's classical. Okay. Rules are always in between 0 and 1. Okay, we know that. Complement. Okay. Okay, the complement is always 1 minus the event, the probability of the event. Okay. Multiplication rule. Again, don't get hung up on the rule for multiplication, but basically it's multiplying the two events. If you have a smaller sample space, that's conditional. So if they're dependent, you should have a smaller sample space for the second one. If they're independent, there shouldn't be a smaller sample space. Okay. And then additive rule, we're going to add and minus what we have in common if they are not mutually exclusive. If they are mutually exclusive, we're going to add and not subtract anything. All right, let me know if we have any questions, guys. We're going to talk more about this next time we see each other. Hope you have a great rest of your day, and I'll talk to you real soon.